Alright, so this lesson is going to specifically address some descriptive statistics of univariate statistics, so one variable stat, and we're going to discuss skewedness of distributions and also box and whisker plots. So, nothing too crazy in this lesson. Let's see, I've already tried to record this today. I've had like technological failures all day long, so let's see if we can get through one. So, we're going to be working quite a bit with our TI-84C. I'm going to use a CE today. If you have an older calculator, I will try to remember to tell you how the entry of the data and how to get your graphs differ, but sorry. The newer calculators have some really cool features. So we're going to be using some old vocab again today: mean, median, mode, standard deviation. It's going to show up a little bit when we talk about skewedness, and then when we talk about our 5-number summary and box and whisker plots, we're going to have to bring back some information about like median, min, max, and then some new things called interquartile ranges. Alright, so first let's talk about skewedness of distributions. So this first one, let's talk about the middle one first. So if you have what we refer to as a normal distribution, my tablet's not working. Okay, just a minute. So when I look at this distribution that's in the middle, your textbook calls this a symmetrical distribution, but later on in the distribution section that comes next, we're going to talk about that being a normally distributed graph. So the mean and median are both in the middle of your data set, and then it's symmetrical on both sides. So it's not skewed or pulled in one direction or the other. Negatively or left skewed distribution, I usually refer to as a left skewed distribution. My husband just took a stats class, and the way he remembered it is he always said the screwed up part of the curve is on the left. So he thought of it as left screwed up, basically, as opposed to a right skewed distribution, where the right side is the one where the tail's all weird. The other idea is all the data is collected in the opposite part of the curve, so and then it's kind of spread out on the other side of the tail. However you want to remember that, go for it. So I am going to ask you, if you were looking at a distribution, whether it's normally distributed, symmetrical, or if it's right skewed or left skewed. You could also use the terms positively and negatively skewed. So, if you're trying to determine whether a certain measure of central tendency is appropriate, you might have to determine that based on the shape of the distribution and if there's any outliers. Mean, median, mode are all good central tendency measurements. But if you have outliers that pull the data in one direction, sometimes the median is more appropriate than the mean. We'll talk about that. So if it's relatively symmetric, the mean and median should be close or similar. Alright, this example is already done for you, and if you don't mind, we're not going to go through this on the calculator because it's just so much information. So what they did is they took all of this data and they entered this into list 1 on our calculator. And then, and if you want to go explore what that looks like, go ahead and type stat, and then go to edit, and then list 1 would be there. You probably have some old data in there from a previous problem. And then they went to the plot and turned it on and selected the histogram option. It looks like a bar graph. And then when they went to go graph it, they just zoomed stat. And we'll talk about this in a moment, but with the newer calculators, that's going to ask you if you have a frequency list or not. In this particular case, they did not have a frequency list. So when the frequency option came up, they just left it as 1, meaning each data value that they entered shows up 1 time in that list. So it took me a minute to remember what that stood for. I had to go confer with another teacher. All right. So when they graphed it and they hit zoom stat, they ended up with this picture here, and then they used the trace feature on their calculator to hop from one bar to the next. So if you hit trace and then keep hopping arrow over, it'll tell you the value for each of these histogram bars. It'll tell you how high up the bar goes, but also the range that's between the beginning and end of it. So your calculator is the one who determined how to spread the data out, how far to make each of the classes, we call them in stats. When we're doing this by hand, that's a little tricky. Like, you have to think about what's an appropriate way to segment your groups of numbers together into classes. So good news is I'm not going to make you do those by hand too much, and if I do, they're already going to be tallied in a frequency table, so that's going to make life really easy. The next thing they did was, because they had their data all entered into list 1, next they went to stat and then over to calc, and they chose 1 variable stat. And then when they hit enter, it gave them all of these 1 variable statistics that gave them a bunch of good pieces of information. So The very first thing it comes up with is the mean, x bar, and then it tells them things like how many things are in the list. It told them the minimum, and then all the way to the maximum. This guy, these set of numbers here, these are called the 5-number summary. And then those 5 numbers are what we're going to use to draw a box and whisker plot in the near future. We're going to do one on a calculator and also one by hand. And you're going to realize they're not too bad to do by hand, especially if you kind of halfway use your calculator. So the 5-number summary tells you the minimum and maximum number, so the lowest and highest. It tells you the middle number, which we know sometimes the middle number is not actually a data value from the list. Sometimes it's the middle of 2 middle numbers. And then the 2 weird ones here, Q1 and Q3. Between Q1 and Q3 is where 50% of the middle data lie. So half of your data fall between roughly 6,338 and 13,800 and whatever. So that's how they basically wrote out an explanation of how spread out the data is based on the 5-number summary. All right, this problem, this is on the next part of the worksheet. I am going to have you enter this in your calculator. So go ahead and pause, and then please enter all of this data into list 1. So you've already entered your data. If not, please pause and do it. And I've entered mine already, I hope, into list 1, yes. So the first thing I'm going to do is I'm going to look at the distribution. So since I haven't graphed anything today, I might have to adjust what's going on in my plot. I turn it on, and I'm going to choose the histogram option. And then list 1 is where my data is, and all of my data values are showing up singularly. There's no frequency list, so keep that as a 1, color whatever you want, and then hit zoom stat, so zoom 9. Here we go. So this data is a little funky. I feel like I typed something in wrong. I don't know. Maybe I did or not. I don't know. Let's see what my window. What did they choose for a window? So for X, you know what? I do have something entered wrong. Oh man. Edit. If I go over to list 1, I think I have like a 2. Ha! Silly me. Alright, that 19. Now I gotta figure out what I missed. Alright, that's a 21. There we go. 1. Right? 19, 21, 18. Okay, there we go. Now I'm gonna go back to zoom stat. Much better. Okay, so this is the distribution that we see. I would consider this skewed left or skewed negatively. There is kind of this weird moment where there's no data here, and that's because there were a couple of 21s, or no, 21s, I don't know, let's hit trace and find out what those are. So okay, they're having this class go from 19.4 to 20.2, kind of weird, right? And then nothing. And then over here, they have 21 to 22, so it's kind of weird how the computer decided to break up the classes. Almost paused my video, silly me. The calculator if you do zoom stat, it chooses the classes based on whatever it feels for the information. But if I go back to the calculator and I set up my window myself, it doesn't really make sense for my calculator to end at 21.8. If I choose to end this at 22, and I count by ones for my x's, I think we'll get a little better picture here. So let's hit graph from there. That's better, that's better. Okay, so again, I would consider this to be skewed left, but you could probably convince me otherwise if you wanted to make a claim. So, I feel like that's not the picture they had. I don't know. I feel like I have... I don't know, guys. Something typed wrong again? I think I'm to the point where I don't care. Maybe when I do this in class for real, they'll actually get it right. Let's go off the data I have. If I have the data wrong, I apologize. Okay, so construct a histogram, describe the shape. I was claiming that it was skewed left, but again, if I have something typed wrong or you want to claim otherwise, that's fine. Summarize the center and the spread of the data using mean and standard deviation, and then the 5-number summary. So for me, for my data, which again, a little concerned I have it wrong, let me just go to my added list. 2020, 20, 18, 20, 18, 18, 19, 19, 19, 21. I don't know. This is how it goes in class too, huh, kids? Alright, 21, 17, 20, 19. Alright, well, I'm feeling like my data is entered properly, so I'm going to go with my information here. I'm going to go to Stat, over to Calc, one variable Stat. Remember, I don't have a frequency list, so keep that empty. If you're using an older calculator, you're just going to do one variable Stat, and it'll assume you're in list 1. But if you wrote it somewhere else, that's fine. So I'm going to jot down that the mean is 19.3. Let's jot that on my paper as well. And then the standard deviation, we'll go ahead and use the sigma one, even though it's not technically a population, but that's okay. 1.05 is a good answer. And then I am going to write down the 5-number summary. So min is 17, Q1 is 18.5, the median is 19.5, Q3 is 20, and the max is 21. Okay, so jotting that down, the way we describe this in words now. So just summarize the center and the spread of the data using the mean and standard deviation or the 5-number summary. So here's the idea. If you feel like your data has been skewed significantly, the 5-number summary might be a little better of a choice. If you feel like your data is pretty normally distributed, then the standard deviation and mean is a good answer. So if you, I already forgot what it was. So if the average was like 19.3 and the standard deviation is 1.05, I mean, I would be okay with you claiming that that is the measure of the distributions, the measures of the distribution. But then if you wanted to go back and explain to me that your what are we even doing here? 20-ounce sirloin, that the weight of the sirloins range from 17 to 21 ounces, with the median being 19.5, and that half of all of your sirloins fall between 18.5 and 20. That would be a good answer. It does seem like that your steaks are a little under 20 ounces because the median is, under 20, and Q3 is actually where 20 hits. So I would basically, my point is I'm going to take any answer you want to give me because you're going to explain it and justify it. And that's the thing in math, is as long as you can justify it with the numbers and the stats, then I'll be okay with that. So as far as what's the answer, I'll take a few different answers. But let's talk about Box of Whisker Plots. So with that data already in our calculator, if you go back to stat plot and you change it to what's called a Box and Whisker Plot. Now there's two different options here. This one right here is the modified Box and Whisker Plot, and this is the regular Box and Whisker Plot. Please choose the regular one. Modified is only used when you think you have an outlier. We'll talk about outliers in a moment. But if I zoom stat that, this is the Box and Whisker Plot. So again, you could trace if you'd like, but this middle line here, this is the median. This is the Q1, this is the Q3, this is our minimum, and this is our maximum. And remember, we already had those 5 numbers from the 5-number summary. So the trick is going to be now, can you graph this on paper? Which, yes, the answer is going to be yes, it's pretty easy. And then can you tell the skewedness from the Box of Whisker Plot this time? So basically, because of the whisker on the left being longer than the whisker on the right and where the median falls, I would claim this is skewed left, or negatively skewed. It's not super skewed though, so if you wanted to justify to me that it's almost normal, I guess you could. the important part is that you can figure out whether you, what the interquartile range means, and that's a new vocab word for us here. So this, the length of the box, the range of the box, this is the interquartile range, which means 50% of your data points fall within this box. So remember, if I hit trace, I already forgot what the numbers were, but it's going to pop between the two of them. So between 18.5 and 20, that's where 50% of your samples fell between. That's what that means. All right, moving along. So I'm going to skip ahead if you don't mind. Back to Box of Whisker Plots. So negatively skewed, positively skewed. So basically for Box of Whisker Plots, you look for the length of the whiskers and where the median is located. And if you have a longer left whisker, then you have a left skewed or negatively skewed Box of Whisker Plot, as opposed to the, oops, I did the backwards, left whisker, right whisker. All right, so I think with your technology, you just choose which plot is easier for you to recognize. I think the Box of Whisker Plots are pretty easy to see the skewedness if you look at the whiskers. All right, here's what a Box of Whisker Plot truly means. It is the 5-number summary, and it's 25, it basically takes it and cuts it into quartiles, starting at your minimum value. So 25% of the data is in the whisker, the first whisker, and then 25% of the data is between Q1 and median, thus the name quartile. 25% of the data falls between the median and Q3, and if you add these two together, you get 50%. And then the last whisker is the final 25% of your data. So it's showing you how spread out your data range is. And it's kind of juvenile looking, and it's named definitely something that's really juvenile, but I think it's a good way to visualize data. So this question, they want us to do this one by hand. I'm going to cheat a little bit because the by hand part, I'm just going to actually physically graph it by hand. So what I'm going to do is I'm going to get the 5-number summary from my calculator. So this on my calculator, I'm going to find the mean, well actually, you know, we can do that by hand too. So they're not quite in order though, guys, right? So we got a 5, and then another 5. Let's see, 5, 5. We got a 7 and a 7. And then we have an 8. This is so much easier to do when I'm in class because you guys will help me catch my mistakes. A 9, 9. A 10. 11. And a 13. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Alright, so get them right. The median, remember if you keep knocking them off one at a time. The median is right in between these two, right? So median is 8.5. And then Q1 is going to be the middle of the next two. So if you don't want to do this part by hand, I can totally understand that you would do your 5-number summary on your calculator. So you'd enter all this data in any order into list 1, do 1 variable stat, and find your 5-number summary. I'm going to do that real quick if you don't mind, just because I don't want to mess this part up. I feel like I'm about to mess it up. So be back in like a minute or a second. All right, so the min and max are very clear. Min being 5 and max being 13. And then Q1 and Q3 are the middle of the middle. You're going to think of it that way. So the problem is you have to remember that the middle is 8.5. So when you start crossing things off, this guy right here is actually the endpoint for Q1. And then, let's see, 10 right here. This is the midpoint for the other part of the whisker here. So the beginning of Q3, 10. I said that really stupid. Timeout. If you do your 5-number summary on your calculator, it'll clearly tell you min, Q1, median, Q3, and max. If you're doing it by hand, what you have to remember is that the median, middle right here, is the end point. From here to here, you have to find the median again. So you start crossing them off beginning and end like we did before. Okay, I just paused the video, and I think I might have messed up something on it, so I'm sorry. I hit the playback button, and I don't know where it picked up again, so I hope it's in the right spot. Here we go. So I have my 5-number summary, whether it be by hand or via the calculator, it doesn't matter. But now when I go to graph it, you graph just like on a coordinate plane. Oops, so it's supposed to be a line. And your first end of your whisker is your minimum, so it'd be at 5, and then the other end is at 13. And you would, make equidistant tick marks like you always would. Q1 is 7. Median is 8.5. Q3 is 10. And I don't think I spaced this out super well, but your box part of your Box of Whisker Plot goes from here to here. This is where 50% of your data lies. The whiskers component goes from here to here. And the right whisker does seem to be a little longer. This is what it's supposed to look like if I could actually graph well. And you could justify that this was skewed to the right or positively skewed slightly. But what we're going to do next is talk about whether or not there's an outlier. So there is an outlier. I don't know why that became a Q. Let's try that again. Outlier. Anything that is 1.5 times beyond the interquartile range. So when you find what's called the interquartile range, which is Q3 minus Q1, so for our problem here, that's 3. And you take 3 and multiply it by 1.5. You get, should totally be able to do this, right? So what is that, 4.5? That's the magic number for how far out from the box you can go without being considered an outlier. So from 10, you're good until you get to 14.5. Because that would be 4.5 above 10. And then from 7, you're good until you get to 2.5. So as long as you're within these boundaries, none of your data is considered to be an outlier. So I don't have outliers, which means basically you can justify almost any answer to me at this point. If you want to say your 5-number summary is the way to justify how spread out your data is, and where 50% of the data is, that's great. And that's what we've been practicing here. So if you tell me the median value, what are we doing here this time? The number of boxes in a stack. Ooh, important information. So the median number of boxes in each stack is 8.5. So between 8 and 9, because you can't have 8.5. And then 50% of the stacks have between 7 and 10 stacks, boxes stacked in their stacks. God, what a weird problem. Okay, so if you'd rather do one variable stats and tell me the mean and the standard deviation as for measures of central tendency and how spread out your data is, you could justify that to me with your data. I'm okay with that. This is not super skewed data, so basically I'll accept any way you want to display and justify your data to me. I know, that's super helpful, right? Interquartile range, remember it's the distance between Q3 and Q1. If a data point is more than 1.5 times the interquartile range outside of the box, that means it's considered an outlier. So that Box of Whisker Plot that the option that we saw that was called modified on the calculator, this is what it's going to look like if you do a modified Box of Whisker Plot, where it's going to mark them as little like stars on the graph, and it's going to take them out of the data, because what happens then is it pulls the data and it makes this really elongated whisker that doesn't actually occur if you just remove that data piece. You know, we've talked about what an outlier might be in a set of data and why an outlier might occur before. So just keep that in mind if you're looking at what is clearly an outlier. Like here, it's the number of Oscar-winning actresses. So, like here, if I'm just scanning through the data, I'm thinking like the 74 and maybe even the 61s. They seem to be really far away from the rest of the data in the list, so those might be considered outliers. I'd have to do that little 1.5 times the interquartile range to see if they're outliers, or your other option is to enter the data into list 1 and then choose a modified box of Whisker Plot on your calculator and see if it ends up graphing something that looks like this when you hit zoom stat. If it does, you got outliers. If it doesn't, you don't worry about it. All right. I think the rest of the worksheet is pretty much going to be like samples that you're going to do for homework. So I don't want to do a ton of work on this lesson because it's just a quick version of how to get things on our calculator. So just a quick rundown again, guys. In your calculator, one variable stat data goes into primarily list 1. If you have a frequency list, you want to keep that in mind, but I haven't been giving you frequency lists on these questions, so far it's pretty much just been in stat edit and then enter your data into list. It doesn't matter where, just remember where you put your data. If you go to stat calc and choose one variable stat, that's where you can find mean, standard deviation, and also your 5-number summary. Your 5-number summary is what you can use to graph a box and whisker plot. The other option for showing that distribution is to choose Box and Whisker Plot on your calculator. If you are concerned that you might have outliers, choose the modified Box and Whisker Plot as opposed to the regular Box and Whisker Plot. If you don't care, then just choose whatever. If you want to look at uniformity of the distribution as a histogram, you would choose this option. Remember, zoom stat for histogram doesn't always work because your calculator is going to set up the classes by itself. It might be smarter if you set up your window for your x's without the calculator's help. Just throwing that out there. And that pretty much summarizes what we just covered. Sorry, I hope that lesson wasn't totally messed up. This is now the 4th time I've recorded it, and I'm done.